Page 16 of quadratics. Okay, find the values of m for which the lines y equals mx minus 2 are tangents to the curve with the equation y equals x squared minus 4x plus 2. So basically what we're doing here is this is a quadratic and this is a line, and what we want is for the quadratic and the line to be tangent, touch at one point only. Okay, exactly. So the way we do that is we set them equal to each other. So we'll have the red equation equals the blue equation, and then we're going to put everything on the left side. So then we'll end up with, like, you know, the purple equation or the green equation. It'll be the combination of the two equals 0. And then when this green equation only has one real root, when the discriminant equals 0, that's when it touches only at one point. Okay? So let's try it out. Okay. So first thing I'm going to do is I'm going to write the two equal to each other, because that's how we find when they intersect. Okay, so when these two are equal, that's when they intersect, and we want to make it so that they intersect only at one point. Okay, so let's make it into a quadratic on the left side, 0 on the right side. The way we do that is we combine like terms. So instead of minus 4x, we're going to subtract mx from both sides, so we're going to end up with minus 4x minus mx, okay? And then instead of plus 2, we're going to add 2 to both sides, so then we get plus 4, and the right side is now equals 0, which is what we wanted, right? If we have a quadratic equals 0, then it's actually possible to solve. Okay? So we want to know when this expression is going to have one root, and that happens when the discriminant equals 0. And so let's take our b squared, our a, and our c and combine them in a discriminant expression. So it'll be negative 4 minus m squared minus 4 times a times c equals 0. So when does this happen? Well, let's expand negative 4 minus m. So it's equal to 4 squared minus 8. Oh, wait a second. Negative 4 times minus m gives us positive 4m. So actually, the middle term would be plus 8m. And then plus m squared. Okay? You can take that really slow, do FOIL on another piece of paper, and make sure that you believe me. And then minus 16. Now let's combine the like terms again. So now we're going to make this into a quadratic with the variable m. So we got m squared plus 8m, and then we have 4 squared minus 16, that equals 0. So we want to know when this is equal to 0. Well, that happens in two cases. All we need to do is factor this. M times m plus 8 equals 0. So the two solutions to this are m equals 0 and m equals negative 8. Those are the two m values which make this tangent line touch exactly this line. Okay? So those two tangent line equations would be 0x minus 2, so y equals negative 2. That's actually a horizontal line. And the other possibility is y equals negative 8x minus 2. Okay? So let's graph these just to see what they look like, okay? So we'll turn on our calculator. And I will put the first expression is going to be the quadratic. So I'm going to put x squared minus 4x plus 2, and then I'm going to put y equals negative 2. And hopefully we'll have a quadratic with a, yes, we have a tangent line because it touches only at one point. Okay, so we checked our answer and it worked. Let's try the other one, y equals negative 8x plus 2. So negative 8x plus, or minus 2, sorry. Minus 2. Graph. This is going to be a diagonal one. Okay, so that is also tangent. So those two solutions look good. All right. So those are the two solutions, 0 and negative 8. Let's do 7. For what values of c do the lines y equals x plus c never meet the parabola with equations y equals 2x squared minus 3x minus 7? Okay. So, basically this is another way of saying, find the tangent line, find what c value makes this line tangent to this parabola, and once you find it, lower the c value or raise the c value from that point, and then the line doesn't even intersect the parabola at all. Okay, so the first part is the same. We're just going to set them equal to each other. Combine like terms. So this will be minus 4x because we're going to subtract x from both sides. Minus c minus 7 minus c equals 0. So that's like the constant value. And then we're going to find the discriminant, and we'll try to find when the discriminant equals 0. So it will be it'll be b squared, so our b is negative 4 squared, minus 4 times a times negative 7 minus c. And so this is equal to 16 minus 4 times, negative 4 times 2 is negative 8, and negative 8 times, I'm going to multiply this negative times these negatives, and so I'm going to get negative 8, I'm going to get positive 8, and then I'll have 7 minus c inside, and then I'm going to expand this, so 16 plus 56 minus 8c, that'll be plus c actually. And then this would be equal to 56 plus 16, which is 72 plus 8c equals 0. So what values of c would make that 0? 72 equals negative 8c. c is equal to 72 divided by negative 8, which would be negative 9. So c is equal to negative 9 is when the line is tangent to the parabola. So let's test that. We're going to put it in the calculator. So we're going to put 2x cubed minus 3x minus 7. And then the line is x plus c, or x minus 9. X minus 9. And then we'll delete the extra stuff, and then we'll graph it, and hopefully we will see a parabola and a tangent line. Or actually, it's, what? No, I typed something wrong. 2x squared, sorry. What am I doing? Graph. Okay, perfect. Yeah, there's the tangent line. It's tangent at that point right there. Okay, now what we need to do is move the line lower, and it's not going to touch the parabola anymore, right? So I would say if c is less than negative 9, then it's not going to touch anymore. So we can test that by changing minus 9 to minus 10. And then we'll see that it doesn't touch anymore. Ta-da! Okay, so any value less than negative 9 is going to cause these two to not touch anymore. And I'm just going to do like a value that is like -8, and then I will show you that it starts to intersect in 2 places instead. See? Okay. Perfect. Last section for this page. So there's a lot of examples in the book you can look at. So these are like word problems, and these word problems result in a quadratic, and then we solve normally for the x-intercepts of the quadratic, and that's going to give us our solutions, okay? You might not see how these are quadratic problems until you start writing the equations that the words tell you to write, okay? So 2 integers differ by 12, and the sum of their squares is 74. Okay, so I got an integer x and an integer x plus 12. Okay, so those are 2 integers that are different by 12. You could also say x and x minus 12. And the sum of their squares is 74. So if I square each one and I add them together, I get 74. Okay, so I'm going to expand this, and I'll get x squared plus 24x plus 144 equals 74. Then I want to make this into a quadratic with everything on the left side, so it'll be 2x squared plus 24x minus 144 minus 74, so it's minus 70 equals 0. Okay, so this is the part that was, the quadratic concept part. We made a quadratic out of this word problem, and now it's all ready to solve. And remember, there's several ways of doing this, including factoring. I'm going to factor 2 out of everything just to see if it becomes something easy to factor. Okay, kind of. Okay, so I can kind of see that now the factors are going to be x minus oh, yeah, this was actually plus, wasn't it? I can see there's something wrong here. So do you see how 144 minus 74 is plus 70? Sorry about that. So this is plus 35. So yeah, I can factor this. It's going to be x plus 7 times x plus 5, right? That factors it. Now I know that the solutions are x equals -7 or x equals -5. Okay? And so the other so like one of the solutions would be -7 and then whatever's 12 above that, so that would be 5, right? And the other one would be -5 and whatever's 12 above that, which would be 7. So those are the 2 pairs that satisfy this statement. Okay? For example, 25 plus 49, which are those 2 squares. If you add them together, you get 74. So perfect. Okay. All right. Now let's do number 3. The sum of a natural number and its square is 210. A natural number is just a whole number, a positive whole number. The sum of a natural number and its square is 270. Find the number. Okay, so the sum of a number and its square is 210. Find the number. Okay, so we're just going to arrange it as a quadratic. So we're going to subtract 210 on the left side and set it equal to 0. Is this an easy thing to factor? What are 2 numbers that you can multiply together and have a difference of 1? It's not 21 and 10. Is it 7 and 30? No, that's even worse. Okay, I give up. I'm just going to use the calculator. Okay, apps. It's probably like, is it 14 and 15? Is that what it is? 7, yeah, it's 14 and 15. Okay, I get it. All right. While I was doing poly-SMLT, I figured it out. So it's x minus 15 times x plus 14. Right? No, sorry, I got them reversed, right? Okay, so it's x plus 15 and x minus 14 equals 0, right? And so x is negative 15 or x is 14. And I know that negative 15 is not an answer because it's not a natural number. So the only solution is 14. Okay? The product of two consecutive odd numbers is 255. Find the numbers. Okay, so we got x is one number, and the next, so let's say that x is an odd number. The next consecutive odd number would be x plus 2, right? So I'm going to now multiply them together because it said the product of these two odd numbers is 255. And then I'm going to have x squared plus 2x on the left equals 255. And then I'm going to subtract 255 so that I get everything on the left side equals 0. And now that I don't even know what the factors of 255 are, let's just do poly-SMLT, okay? So the way we do poly-SMLT is we say it's order 2 because it's a quadratic, and then we say next. And then we're going to put in the, the coefficients. So 1, 2, negative 255. 1, 2, negative 255. Enter, or solve. And the two possibilities are negative 17 or 15. Okay? So, what would be the next odd number if it was negative 15? The other one would be negative 15, right? And what's the next odd number after 15? It would be 17, right? Okay, that makes sense. So, like, the two pairs would be negative 17, negative 15. If you multiply those two together, you get 255. Or 15 times 17. If you multiply those two together, you get 255. Okay? One more to go. The length of a rectangle is 4 centimeters longer than its width. Okay, so the length is x plus 4, and the length and the width is x. Does that make sense? So the length is 4 longer than its width. The rectangle has an area of 26. Find the width. Okay, so we know that length times width equals the area. So we can make that equation. And we are well on our way to solving this problem because we have already written our quadratic. Let's see if we can factor this. I know I told you that you don't have to factor, and if you are not following my factoring, just do quadratic formula, okay? You're only going to have like one of these problems on the exam. If you take 45 seconds to do it with poly-SMLT instead of 15 seconds to do it with factoring, no problem, okay? 26 only has a couple factors, integer factors, 13 and 2. I don't think it has any other factors, so maybe it's going to be a decimal, in which case all this factoring is for naught. Okay, let's try here then. So what is our A value? It's 1. What is our B value? It's 4. What is our C value? It's negative 26. Solve. Okay, two weird looking numbers. So, yeah, do you see, like sometimes you're like, okay, I'm going to factor because all the ones before this I could factor, and then you start factoring and then you realize, okay, waste of time. I just wasted time. So the two possible x values are 3.48 and negative 7.48. Why do we reject negative 7.48 as the solution? Because our x value is supposed to be a dimension, and dimensions can't be negative. So our only solution is 3.48. Okay? So 3.48 is the width. So we're done.